Ladies and gentlemen of Algebra 2B, welcome to 8.2. This is talking about inverse functions and relations, and what we're talking about here is what does it mean to be an inverse? All right, you need to be able to find the inverse for a function and a relation and be able to tell me kind of what those are and how they operate. So let's talk a little bit about a relation. A relation is nothing more than a set of ordered pairs. So you have this. So your domain is going to be all your x values. Oh, sorry, there's not a 2 in there. 3 and 5. Then your range is going to be 2, 4, and 6. So an inverse relation is a set of ordered values found by reversing the x and y values. So the inverse relation now is going to be this. So your domain is going to be 2, 4, 6, and your range is going to be 1, 3, 5. That's all an inverse is, just switching what the domain and range are. So the ordered pairs of the relation 2, 1, 5, 1, 2, negative 4 are the vertices of a right triangle. Find the inverse of this relation and then graph the two relations. So your inverse then is going to be 1, 2, 1, 5, negative 4, 2. All right, so that's going to be, so 2, 1 will be right here. 5, 1 will be right here. 2, negative 4 will be right here. So there's your original right triangle. So then when I go to the inverse, so that's going to be 1, 2, 1, 5, negative 4, 2. There is your inverse. And if you notice, it's reflected about x equals y. So it's reflected over what I call a perfect diagonal. It's reflected over the line x equals y. Okay, so if I draw a line, there's connected, connected, connected right there. That's how an inverse works. So figure out the inverse of x plus 2. The easiest way to figure out the inverse function is to set up your original function, but put y in instead of f of x, and then to figure out the inverse, switch your x and y and resolve. So now solve for y. So subtract 2, so x minus 2 equals y. So your f inverse is going to be x minus 2. All right, so for f of 5, that's going to be 5 plus 2 equals 7. And if I put 7 into the inverse, 7 minus 2 equals 5. That works. Went from 5 to 7, then went from 7 back to 5. That's what I want to have happen. So find the inverse of x plus 6 divided by 2. So again, I'm just going to say, you know what, y equals x plus 6 over 2. Then I'm going to switch. Now I'm going to resolve for y, so I'm going to multiply both sides by 2. That cancels out. 2x equals y plus 6. So f inverse of x is going to be 2x minus 6. There's my answer. So the inverse of 5x plus 10. All right, it's plus, you notice you're adding 6, dividing by 2. When you put it together, you're multiplying by 2, subtracting 6. There should be an element there, so that's kind of your mental check. Am I doing that? So if y equals 5x plus 10, so switch and resolve. So I'm going to subtract 10. Divide by 5, so y will equal x minus 10 over 5. And if I left it like that, that would be fine. So that's your inverse, just switching those two around. So now, determine whether these two things are functions. Well, one way to do it is to put in a number, see what you get, and then put that answer into there. So I can put a number into here, and you'll get a number. Then I put that number into g of b and see if I get a. See if I get the number I started with. All right, so 3/4 x minus 6. So if I just I don't know, I'll let x be, I don't know, 8. So I let f of 8, so that's 3/4 of 8 minus 6. So I picked 8 because I know I'm going to divide by 4 right away. So I just picked 8 because I know 8 could be divided by 4. So this becomes 6 minus 6, which is 0. So now let's check g of x and put that back in and see what I get. So if I put g of 0 in, that's 4/3 times 0 plus 8. Well, that's 0 plus 8. My answer is 8. Is that what I started with? Yes. Yeah, that's going to be an inverse. You could also do it algebraically by putting one function inside the other. So what I mean when I say that is this. So I'm going to put g of x in for x for the other function. So if I want to look at that, let's come up here, kind of work backwards here. So I'll take 3/4, but then I will put 4/3 x plus 8 minus 6. So I'm going to put this whole thing in for x. So now if I distribute this, if I multiply these two, they cancel out. I'm just left with x. All right? 3/4 of 8 is going to be 6 minus 6 from out here. So I'm left with just x. That's what I want. If those are inverses, yes, that's what I want, just x. So all I did was put one in for the other and then see what happens when I simplify it. So find the inverse of pi r squared. So all I'm going to do is, switch this around. So if I have y equals pi x squared, switch that around, so x equals pi y squared. So solve it. So I'll have x over pi, then square root. So that's the square root of x over pi will equal r. So the inverse will tell you the radius. Okay, so find the radius with a circle of 314. So take 314 divided by pi, take the square root, and when you do that, that'll give you the radius. 314 divided by pi is going to be about 100, approximately 100, and when I take the square root, I'm going to get 10 for an answer. So that's going to be my radius. So when is this useful? This is useful especially here. So this is your function to convert from Celsius to Fahrenheit. So find the inverse. So y equals 9/5 x plus 32. So switch x and y. So when I start solving this, so that's going to be x minus 32 equals 9/5 y. So I'm going to multiply both the top and bottom by 5/9. So 5 divided by 9 times x minus 32 equals y. So there's my inverse. So if the original function can go from Celsius to Fahrenheit, what do you think the inverse does? Well, I'm really hoping you say, well, you know what? The inverse goes from Fahrenheit back to Celsius. There's my answer. All right? All right, play around with this. Make sure you hit submit at the end of the Play Positive video if you're watching that, and come talk to me with questions.